Mac 1105 College Algebra, Chapter 3, Section 5, Part 1. We'll do this in two parts. Okay? First part just deals with what we call the library of functions. And you just have to know the library of functions. You'll see why in Section 6 when we do transformations. One of the things I require in all my problems dealing with this is the fact that you include three ordered pairs on any graph. Okay? This is important. So if it's f of x equals square root of x, your three ordered pairs are 0, 0, 1, 1, 2, 4. Never change. Unless we get into transformations, and I'm going to talk about how x or y are affected by the transformations. So you got to know the square root graph. Got to know the cube root graph. Three ordered pairs for the cube root graph are 0, 0, 1, 1, negative 1, negative 1. You got to know this. The three ordered pairs for the absolute value function are negative 1, 1, 1, 1, 0, 0. And all I'm doing here, and so if you look at this, the ordered pairs are negative 1, 1, 0, 0, 1, 1. Now, if we go back to the cube root graph, we can see that it's odd. The reason it's odd is because remember when we talked about the cube root function, see how it's starting here in the first quadrant? It would flip over the second quadrant and then flip back down to the third. Anytime a graph flips, just two flips basically, and your x's change sign, and so do your y's, that means it's an odd function. In terms of the absolute value function, this is even because we only have a flip over. Here, the x's change, but the y's do not. We come down here to the square function, which is the quadratic function. Basically have the same ordered pairs that we do with the absolute value. Negative 1, 1, 0, 0, 1, 1. Again, the square function is even. Okay. We come here, and now we have the cube function. Now this is not the cube root function. Look at the difference between the two. Even though they share the same three ordered pairs, the way they're written or drawn is differently. The cube function is odd as it flips over and then down. Then we have what we learned was the horizontal line where f of x equals b. Make sure you understand that little b means y. So this is a horizontal line going through whatever b is. We have the reciprocal function. Now I'm not going to give you anything on a test with the reciprocal. That can happen if you go on and take pre-calculus or whatever. The reciprocal function has what we call asymptotes. These red dashed lines that I put here are asymptotes. We'll talk about asymptotes later in another chapter. I only put one ordered pair there because, like I said, I'm not going to give you a reciprocal function. I'm going to go over an example of a reciprocal function later, but beware that I'm not going to give you one on any kind of test. And then the last one we have here is the slope-intercept form, which is a function. Any straight line, any straight slanted line is a function. What I've done here is shown that if it was a positive slope, positive m, it's going to rise from left to right. If it's a negative slope, it's going to fall from left to right. Okay? So in terms of all these are graphs. Going over them again. Got to know the square root function in those three ordered pairs. Got to know the cube root function, those three ordered pairs. Got to know the absolute value function in the graph of all these, and those three ordered pairs. Got to know the square function in those ordered pairs. Cube function in those ordered pairs. There's your horizontal line. The reciprocal function is one of your library of functions, but I'm not going to give you one on a test. And then your slope-intercept form of equation, your linear line. Got to know these.